Hello guys, welcome back. Now it's time to solve another Leetcode problem. This time we're solving the Leetcode number 1315, which is the sum of nodes with even valued grandparent. So it's a medium level question. Yeah, let's dive into the description. So they say, given the root of a binary tree, return the sum of values of nodes with an even valued grandparent. If there are no nodes with an even valued grandparent, return 0. And then there is a note here: a grandparent of a node is the parent of its parent if it exists, basically. So quickly here, they give us an example here. So this is the binary tree. We have the root node here, which is 6. We have, if you go left, we have the first child, which is 7. If we go left again, that's the first grandchild here. So 2 is a grandchild, 6 is the grandparent, as you can see here. So that's a grandparent, that's a parent, and grandchild. So as you guys can see, all of the nodes in this level here, they have the same grandparent, which is 6, of course, and 5 also have a even grandparent, which is 8. As you guys can see here, this question asks for a recursive solution. Usually three questions, they usually go well with recursion. I can see here that we could go left, then go right, and then go back to the node. So we're going to solve this problem using a post-order recursive function. And yeah, let's dive into the code. So just leave here the tree. Let's do a recursive solution here. First thing is to check if the root given to us is null. If it is, then there is no even grandparent. Actually, there is nothing. Then we simply return 0. Okay. Next step here is I'm going to create the recursive function itself that will solve the problem for us. I'm going to call it DFS. And as we can see here, in order to process the node, we need to know about the grandparent. So I'm going to pass to this function the node itself, the parent, and the grandparent. So in this case, for the root node, we have no parent or grandparents because this is the first node. Then we can start coding our function. So it's going to be a private int DFS. It's going to receive a root node or a node itself, its parent, and its grandparent. First thing is to finish our recursion. If the current node is null, then simply return 0 because we didn't find anything. Next step is to go left. We have to go left first, go right next, and then we process the node itself. Okay, we keep going left. So I'm gonna make another recursive call here, DFS root.left. The parent now is gonna be the root itself because I'm just passing, for example, 7 here. 7 is the node I'm passing. Root is the parent, and I have no, and I'm gonna pass the current parent as a grandparent, which in this case here, that's gonna be null. So for 7, but we're gonna have it populated once we reach the node number 2. Likewise for right, DFS root.right, root and parent. Okay. Now, yeah, I'm gonna create my variable here, sum, which is the sum of the nodes that they have even grandparents. It's going to be pretty much left and right, whatever I get back from the recursion. And then I'm going to process the node I am. Simply, I'll check if grandparent is not null and grandparent, the rest of the division by 2 is equal to 0, which signals an even number. If it is, then I'm gonna simply sum my total here with the current node.val, and then we have to return sum, and then the recursion will take care of things for us here. So just a quick recap here. We start here the function, just checking if the root node is null. If it is, then return 0. If it is not, then we call our recursive DFS, passing the node itself, parent and grandparent. Yeah, and then we recurse left first, then we recurse right, always passing the parent and grandparent. And the last step is to process the node itself after the recursion unwinds. Yeah, that's pretty much it. We can try running our code now. And yeah, it was accepted. So let me try submitting. Yeah, that's good. Okay, it works nicely. This was the first solution, which was recursive. We can also have an iterative solution, which I'm going to solve right now using BFS. Let me just clean everything up. As it's iterative, I'll have to simulate how recursion works. That's not difficult. Let's start having our check here. If root's null, return 0. Next thing is we have to create a queue, which I'm going to create a custom class here, element that's going to contain the information I need to pass, which is the node itself, its parent, and its grandparent. Element queue, new array the queue. Just 1 second here. Private class element. Yeah, this class it could be called anything, but I decided to have it called element. Let me just paste this code here just to speed things up. It's basically the same information I typed for the recursive solution, but now I have to create a container because we don't have recursion here to pass things to the next level. Okay, I have my queue here. Then I'm gonna add the first element here. Let me just format this code here. Sometimes it doesn't work. Queue offer new element. Then there's gonna be root, no, and no. So parent and grandparent. Let's remove things here. Now I'm gonna execute my BFS here while the queue is not empty. Then I'm gonna process those nodes. So element is equals to queue.poll. That's just gonna give me the next element I need to process. Node, e node, entry node, parent, e parent. So I got the current node and the current parent. And I also need the grandparent. Then I'm going to do exactly the same check as we were doing for the recursive function. It's not null, and grandparent dot val the rest of the division is equals to 0. If it is, I need my sum variable here again. So sum plus equals to node dot value val, and that's it. So next step is to add the children on the queue as well. So I'll check if left is not null. Queue offer new element root dot left. No, actually node dot left. Node and parent. Likewise for the right node, if it's not null, queue dot offer new element node dot right, node and parent. And last step here is simply to return the sum. Okay, just a quick recap here. Yeah, just checking if root is null, then we create our custom container here just to hold node, parent, and grandparent. We add to the queue, and then we process the queue until the queue is not empty. That's how BFS works. We get those elements here. We could simply have used e dot something, but I think doing this way makes things a bit clearer. And then we simply check if the grandparent is not null and the rest of the division by 2 is 0. Then we sum the value. And if left is not null, then we add to the queue. If right is not null, then we add that to the queue as well. Let's try our code. Should work. Yes, works fine. And then let's submit our code. Perfect. It works perfectly. I hope you guys have enjoyed. Please give a like and also subscribe to the channel, so that helps us a lot. And also leave your comments in the description below. See you guys next.